6 to 7 years. So now coming back to this, marine application. So if you look at this marine application, basically, vessel, they cruise at a constant speed. When it is a constant speed, means you need a constant power. And if you look at the fuel cell technology, you take any technology, we are working on the PEM fuel technology. So this technology basically, mean for a constant power output. So this, inherent capability or the characteristics of fuel cell complement the requirement from the marine industry. And based on this methodology, we are building the entire system for this vessel. So this is one thing. Another thing is the thermal management. The thermal management is very critical in the fuel cell. Here, almost your 40 to 50% of your auxiliary power goes into managing the thermal management. So when I say vessel, so here we can take advantage of the seawater as a secondary coolant media, and thereby we can reduce the auxiliary power as well. So this is the second advantage where I can see the fuel cell can fit into the marine application very well. So this is one. The third thing is the complete hydrogen storage system. Now, if you look at the storage system, we can have the storage system either on the deck or on the roof of the vessel. Then we have a indigenously developed electric traction motor. Here, traction motor is developed, keeping in mind the specific requirement of the marine industry. So here we are eliminating the gearbox. So you can have the motor directly coupled to the it's a direct drive motor. So you have a lesser conversion loss here. So, these are the some factor which we see as a advantage, when we use use the complete fuel cell system for the marine application. So this is one thing. Another thing, we talked about the retrofitment as well, right? So when I say retrofitment, so we have tried doing a retrofitment on the in-use bus and the car. We have converted those car and buses on the fuel cell, and they are giving a fantastic performance. We are doing the road trials. Same we can apply in the marine industry as well. So for that we are just collecting the information. We are in a phase of gathering the requirements, and once this pilot project gets kicked off, maybe somewhere in the next year, you will see the India's first vessel, fuel cell vessel, running on the waterways. So I think after that, after collecting the data, we'll also devise or develop a solution for the retrofitment market as well. So this is what KPIT is working in the fuel cell segment.
Thank you, Kiran, for that insight. Yeah. So now it's time to. Thank you. It's a time for me to turn to the experts, colleagues from Classification Society. So I'll first go to Devrup Kabi from Indian Register of Shipping. Devrup, can you provide an update on Indian coastal shipping and harbor craft scenarios? What's so special and why it is unique, and also what are the main challenges we face in case if you go for an alternate fuel uptake for coastal shipping and inland waterways vessels? Is solar power an option for us? Yeah, and so whether solar power can be used for propulsion, charging batteries, or can that be used merely for meeting the hotel load requirement for small passenger vessels? Over to you, Devrup.
Thank you, Chair, giving me the opportunity. So, as we are aware of, the output, 5% of the fuel has to be an alternate fuel. I mean, has to be alternate fuel. And the technology has to be also 5% accordingly, okay? And if you know, I mean, if you hear DG Shipping speaking yesterday, today also Mr. Senthil Kumar, and our convener, Mr. Mudit told, 85% of the vessels are coastal vessels, okay, sir? And out of those 85%, I feel there are 70-80% which are, you know, category 3 vessels, which are of GRT less than 5,000, okay, sir? There are vessels which are 0 to 5,500 GRT vessels. There are vessels which are 1,000 to 3,000 vessels. There are reversible vessels. There are Indian coastal vessels doing only coastal. And what about international? I mean, 20% of the vessels we are doing international. It's supposed to be international. Half of the vessels are doing coastal right now. At any point of time, you'll find 47% or 50% around doing coastal. So at any point of time, you'll have 85% vessel doing coastal. So this is the scenario as it is. So if you are talking about the output, how the output will, now we heard the panelist, and we know mostly it will be like new building, new fitment, okay, where the capex, opex, and everything is involved. Even the supply chain also, that we have to think of. Methanol fueled, methanol ready vessels, ships, ammonia ready vessels. Those are not very easy to, I mean, to accommodate in Indian scenario. As of now, new construction, I can understand new building that's been happening. And I cannot see any yard as of now, they're ready with those sort of fitment. I have to be very blunt on that because, see, if you want to achieve the output at 5% within 2030, this has to be something else, little bit. We have to think of, because if you see the heading itself, this is retrofit on existing ships, mostly. If you talk of 2000 till 2030. And also, we have in the heading, there's a carbon capture is included in that. Okay, that's a new thing. I mean, Shobit will come to that. But coming to this scenario, we have plenty small vessels. That is what I am touching upon. Okay, sir, there are small vessels, 0 to 500 GRT, which are ferries, catamarans. Okay, sir, there are supply vessels, which are not very small, 1,000 to 3,000 GRT. There are tugs, 37%, 40% are tugs only. There are anchor handling tugs. There are supply cum and anchor handling tugs. There are small vessels with very high power. Okay, 1,000 kilowatt till maybe 1,500 kilowatt. Okay, it starts with, I mean, anchor handling tugs, they start with, I mean, supply vessels, they start with 400, 500 kilowatt till it can go up to 1,200 kilowatt. So those sort of engines are there, already existing, not existing vessels. So how to make those existing engines, okay, comply to this 5% requirement? Even the small engines, I mean, 0 to 500, you have 50 kilowatt engine fitted, 50 HP engines fitted. They are in a large number, huge numbers. Okay, we forget coastal right now. We'll go to IV vessel, IV SOC. Lakhs of fishing vessels flying around. They're using kerosene, they're using petrol. I can vouch for that, sir. And how to take care of those? I mean, they're also polluting. They're polluting even water also. Not only atmosphere, I mean air. So how to take care of this, all this? This has to be an output for that. Okay, sir. As I understand, if you talk of alternate fuel, as of now, if you call hydrogen as an alternate fuel with fuel cell, that could be a solution as of now existing. I don't see any methanol replacing as of now. It will replace 100%. CNG, LNG will replace. It will replace, but with certain advanced technology, with methane capture and all that. Even with carbon capture also, you will have many engines fitted in with fossil fuel also, possible. If you are capturing carbon, your fossil fuel you can use as it is, for the existing ships. So those technology are, carbon you can say upon that, but this is in a nascent stage, sir. That is what I feel. And if you ask me, the solution a little bit, what I understand, in a coastal scenario, fuel cell for small ships, okay, so we can have from 5 HP to 200 HP. Kiran also vouch for that. He is from KPIT. I mean, that is what I understand. You can go up to 200 kilowatt fuel cell, okay? And as presently that the pilot project we have been taking in, that is around 45 kilowatt, 2 fuel cells. Okay, that is around maybe 35 length vessel and catering to 100 packs, 150 packs, 150 passengers. Okay, sir. And talking of CNG, LNG retrofits, okay, sir, CNG, LNG retrofits, those LNG retrofits are as I understood, I mean, yesterday Madhu and I was speaking, I was a little surprised. Varanasi, you will have already CNG vessels flying, CNG ferries flying. Okay, sir. So this is another thing like we should think of. Okay, sir. So in that respect, I feel we'll have a very clear-cut solution for all these small vessels, 0 to 500. Cargo vessels, I can understand. We are not talking of biofuel. We can easily use biofuel for 3,000 GRT, 5,000 GRT. But for small vessel, hydrogen fuel cell, CNG, LNG retrofits. Okay, sir. Even for fishing vessel, LPG retrofits. I can vouch there are 100 of fishing vessels now running in LPG. Okay, sir. Much I won't say. I don't want to discuss much about that.
It's fantastic insight, Devrup, about Indian, particularly in Indian scenarios. Yeah. Thank you very much for that. So can I turn to Shobit Kapoor now? Shobit, if you can briefly, we are running short of time. Briefly, if you can mention about experience in hybrid propulsion vessels. I think you're involved in building them in India, in Chowgle shipyards. So my question to you is that, so how do we build those vessels in Indian shipyard for Indian ship owners? And can we manufacture the components of the hybrid propulsion system, particularly the batteries in India? And what are the barriers? And yeah, how about you, Shobit?
Good afternoon, Chairman sir, and thanks for giving me opportunity to speak on the subject. As you already said that Lloyd's register, along with Chowgle, we are building a cargo vessel of dead weight 5,350. This is a highly efficient electric hybrid vessel. Greenhouse gas emission, including CO2, it is expected that for unit of transport work will decrease by almost 50% for these vessels. These are most efficient in the world in its class. So indeed, it's good news for us that our shipyards are building vessels which are one of their kind in the world. Having said that, there have been challenges, some are which are inherent to the technology and some are related to Indian scenario. As it has already been discussed that vessel's battery pack has a concern about energy density. You know, for a same quantity of fuel, the amount of space taken by battery, both from the point of view of volume and weight, would be 10 times higher. So indeed, that's a challenge. But I would like to add something more to it. Battery technology has efficiency which is higher than comparable DG sets or any kind of internal combustion engines. It can go as high as 78 to 80%. So where this volume is not a concern, indeed, it can be advantageous. The second challenge is the hydrogen generation or those kind of safety concerns. Obviously, the standards have come and that should not be a very big concern considering the kind of safety mechanism which will be put in place in those kind of systems. Now coming to Indian scenario, as the space required and number of batteries required would be on a higher side, it has a very high cost implication. Now, because the demand of such batteries and associated equipments is less in India, there are not too many manufacturers who are available here, who can give it at the right cost, which is required for the coastal vessels or increasing this technology, popularity of this technology. So there is indeed a need for more manufacturers to come in with the associated technologies, control systems. Because in this project where we are working on, most of the components and machineries are being imported. Even the design of such systems are being done outside India. So I will just quickly, I understand there's a shortage of time. So there is a need for type approved products being manufactured in India to achieve the cost advantage for smaller vessels. Thank you.
Thank you, Shobit. Quickly, I go to Shobit Hariharan. Shobit, you are involved in supporting novel technologies. Can you provide some insight into carbon capture technologies and the state of readiness of carbon capture technologies briefly? And is it feasible carbon capture technology on board coastal ships and inland waterways? Yeah.
Yeah, thank you very much, Chair. So I will share briefly in terms of the state of readiness for carbon capture systems. So as Mr. Devrup mentions, rightfully, it's really at the nascent stage now. So we see a lot of vendors, especially ex-scrubber makers and all of that, coming up with a number of different technologies. For instance, there are chemical amines based, there are membrane systems, or even cryogenic capture kind of systems. So where are these now in terms of at least installation on board? So we are working with some vendors and trialing some of those on smaller vessels. So for instance, on feeder vessels, MR tankers and all of that, operating mostly in Europe area. So again, these are mostly chemical amines based systems. And in terms of how much of sort of a carbon this can capture, it's quite limited. So totally agree with what Mr. Devrup said. It's really at a really nascent sort of stage. And a lot of this technology will still have to mature. And the regulations that have to cover these technologies will also have to be developed. So that's where it actually stands in terms of the readiness for these systems. So coming back to how suitable it is for these smaller coastal vessels. So for that, we definitely maybe understand two aspects. So if you look at a carbon capture system, we are trying to put additional equipment on board. So for instance, perhaps starting with a scrubber unit and storage for at least these amines and provision for perhaps separating these and all of that. So that means we have to take up a lot of space on board. So if you look at these tugs and patrol boats and smaller inland waterway vessels, definitely there is not sufficient space to handle this at the first place. Then again, we need to think in terms of perhaps including larger vessels. For instance, as Mr. Mehrotra mentioned earlier, a lot of these larger vessels are also operating in coastal trade, perhaps for instance, feeder vessels or general cargo ships.